Okay, so our project is called the Sunflower Sensor. My name is Julissa Ortiz.
And your age.
Basically, this stems from my participation in FGCU's Solar Go-Kart Challenge, where basically you build a solar go-kart that's run on solar energy. And you could either choose whether you implemented the solar panel, like you switched it off depending on what race you were doing. So we did speed, which was basically, speed, you went as fast as you can around the track first. And then they had the endurance, which was you had to do a preset amount of laps in order to, last the longest with speed. So we built ours with 3 solar panels, and I think 2 years ago they implemented the mobility, where they wanted to tilt it towards the sun in order to obtain the most energy. And the first year it worked manually, but the second year we tried to use LDRs, which are light dependent resistors, which are small little sensors that detect light. And it worked manually again, but to automate it, it would drain too much of the energy, so it kept tilting. But pretty much it worked. Just have to fix it, to be less sensitive. The objective here is to create a model that would ultimately mimic the behavior of sunflowers, which is called heliotropism. And by the end of the semester, we hope to have a model kind of where there are different sensors, and they're angled differently in order to, see different directions of light in the position, depending on where the sun is in the sky, but just the sunflowers too.
For the relevance of the biology, would follow the process of heliotropism, which is a directional growth of a plant which follows where the light is. Follow it from east to west, follow the sun to get energy.
And this graph basically shows the movement of planets towards the sun. Like in the morning, it'll start facing east towards the sun, and as the sun progresses through the day, it'll move with it because of the cells, either in the plants or leaves, that tell it to move. And then at the end of the night, they end up on the sunset. But then at night, when there's no light, it'll come back and for the next day. The idea is to build a model in which you use more than, I guess, would be 5 or 6 sensors, each facing a different angle, and the light would hit at different angles, and that would tell you whether the sun was, which position it was in sunset or, middle of the day, and then tilt the solar panel maybe towards the light, and maybe the placement of the sun would determine the placement of the panel.
Potential applications would sort of deal with possibly solar phones, in a more practical sense, solar cars, and would focus with companies trying to switch to solar power.
Because you see the pictures, they're stationary, and they're basically just receiving an angle of light, concentration of light, and maybe in the future they could, make it mobile. I haven't seen many companies trying to mobilize it, and the phones, they tried in 2009, but it was kind of sketchy.
All right. Okay, questions, guys? Questions? Okay, I'll throw the first question. All right, so you're gonna have your solar panel and install all these 5, 6 sensors in the panel. So I would assume that you have motor and your sensor attached to the panel.
Mm-hmm.
And how are you going to control the motor's movement? so that it goes on that specific angle? It's through a computer program or?
Yeah, it's through Arduino software, basically program the steps, depending on what, the concentration of light is at that point.
Awesome. All right. Any other questions? Yeah.
Considering the actual cost of solar panels, they'd be kind of expensive. Is there some sort of new solar panel out there that's going to make this more cost effective, or it's still kind of the same?
Basically, we haven't really gone into the solar panel detail, but the basic concept is, the sensors and, trying to figure out if it will detect light at different angles and, just, focus on that energy instead of the other ones, and, become the main concentration of the whole product.
Alright.
Dr. Ula has a question.
Yeah, I'm just wondering that because you are explaining everything like from the biological point of view. So you said that it's a sunflower sensor. The sensor you are going to make it, or you going to buy the sensor from the market?
We were thinking of buying the sensors from.
Oh, okay. So that means you do not have any proposed design or idea that you're going to make the sensor. So you directly buy the sensor, then use the sensor you're going to utilize this, right?
Correct.
Oh.
Yeah, and I think that's what's going to happen is what they will be doing really is the programming of how that sensor is going to move,
Okay.
because that's what they are. You're
That's the
computer
main
programmers,
point.
right, guys? Yeah.
Yeah. Okay, makes sense.
Yeah, so that makes sense, because then, yeah, they're not the engineers who is gonna make the sensor. Yeah, so they will get the sensor and then install it, hopefully, and engineer can help them, right? And then they'll program. I think the most important thing is the programming of how that moves and goes around. So with that though, there's nothing in the market that actually has thought about this?
Well, the IST basically follows the same concept of, getting the light at what angle and then.
Right, but it's just not designed the way yours. It's gonna be like a sunflower moving in an angle and then going to
Yes, ma'am.
an initial point. Okay, which is good. All right, thank you very much.